solving quadratic equations. A quadratic is when the biggest power in the equation is a 2. If the biggest power is not a 2, it is not called a quadratic. Let's suppose that our quadratic is equals to 4. To solve this problem, you copy the x, just the x, and you copy the 4. 2 times. You duplicate the x equals 4 2 times. This technique to solve a quadratic equation will only work if the quadratic is by itself and there is not an x added to the square. It will only work if the x squared or the quadratic is by itself. Then what you do is put a square root around the side with the constant, and you put a negative in front of one of the square root. It doesn't matter which square root you write it in front of. Then you simplify the square root. X equals the square root of 4 is 2 because you're looking for a pair of numbers. 4 is 2 times 2. One of the pair will come out of the house and the other pair will disappear. Therefore, the final answer is 2 on the outside and nothing on the inside. And the same goes for the other square root. You're looking for a pair of numbers that multiply to be 4. One of the pair will come out of the house, but notice that the negative was out to begin with. It was outside to begin with. So that is going to leave us with x. You have the negative to begin with. One of the pair of 2's will come outside and the other pair will just disappear. And so our final solution is 2, negative 2. In our second example, the quadratic will not be by itself. You have parentheses x, take away 4 to the second power. If the big power is 2, it's a quadratic. But this quadratic will have minus 4. And this will equal a positive 4. You've got to get the quadratic by itself in order to solve the problem. We need to move the minus 4 over to the other side by adding 4. to both sides. Now the quadratic is by itself. And notice there's nothing in front or behind the quadratic. 4 plus 4 is x. Is 8. The quadratic is now by itself. Once it's by itself, we copy the numbers inside of the parentheses and the numbers outside of the parentheses 2 times. We write x minus 4 without the squared equals 8. And then we copy the x minus 4 equals 8 2 times. Now we put the square root around the number on the right side. You can only put it around the right side. And then we put a negative in front of one of the square root. It doesn't matter which square root. I put it on the square root on the right. Okay, now what we do is we move the 4 over to the other side to get the x by itself. We add 4, and we add 4. Same for the other. X equals the square root of 8 plus 4 are not like. So we have to just write it together. You can't add because one is inside of a square root and the other's outside of a square root. And we do the same on the other side. But bear in mind that a square root of 8 has a negative in front. So we write negative square root of 8 plus 4. Again, we can't add negative square root of 8 and 4 because 8 is inside of the house and 4 is outside. You can only add radicals if they have the same exact radical behind the coefficients. Now we need to simplify the solution. The solution was x equals the square root of 8 plus 4, comma, x equals negative square root of 8 plus 4. We need to find a pair of numbers that will multiply to be 8. We know that 8 is 4 times 2. But 4 has a pair of numbers. We have 2 times 2 equals 4. So we're looking for pairs of numbers. Since we have a pair of number here, one of the 2's will come outside of the house, and the other 2 will disappear. Now don't forget that there's this extra 2 that will stay in the house because it only comes out if there's a pair of them. So our final answer for the first solution is 2 comes out of the house and then this 2 stays in the house. And then bring down the plus 4. And so the other one will be worked exactly the same way. 8 is 4 times 2. We're looking for a pair. 4 is 2 times 2. So out of this pair, one of the 2's comes outside with that negative that was out there to begin with, and the other 2 disappears, and we're left with that 2. inside. So the solution for the second x is negative 2, and then we have the 2 inside the square root plus the 4. Our final solution is 2 square root of 2 plus 4, comma, negative 2 square root of 2 plus 4. Our final example is when the quadratic will equal a negative number. So if we have x minus 2 to the second power, there's a number behind it, plus 4, equals, let's suppose we have 6. Or let's say that we have 12, but negative 12. Okay, we again get the quadratic by itself by moving the 4 over to the other side. We end up with negative 4. Negative 4, we subtract 4 on both sides. And we have the x minus 2 squared. There's our quadratic. But this time it equals a negative number, 16. Once the quadratic is by itself and there's no x added to the quadratic, we can proceed with our steps. We copy the number inside and the number outside 2 times. Quadratics always have 2 solutions, so you need to copy this 2 times. Then what we do is we put a square root around the side that has the number, the constant, or the right side. We put the square root around the constant side, or the right side. And then we stick a negative in front of one of the square root. It doesn't matter which one. Then we solve for x. We get the 2, we move the 2 rather, over to the other side by adding. And we have x equals the square root of a negative 16 plus 2. And the other x is x equals a negative square root of a negative 16 plus 2. We now need to simplify the square roots. The solutions again were x equals the square root of negative 16 plus 2, comma, the other solution, x equals a negative square root of a negative 16 plus 2. Again, we're looking for pairs of numbers. Keep in mind that negative 16 is not a square. To get a negative, the numbers would have to be one negative, one positive. So what we do is we break down just the 16 using 4 times 4. 4 times 4 equals 16. And the negative, just the negative, is also a pair of numbers, but it's an imaginary number. I times I equals -1. So keep in mind that I times I stands for an imaginary number, equals -1, where I equals the square root of -1. Keep in mind that the number outside must multiply to give us the number inside. So I times I, we know, must equal -1. We look for a pair of numbers. Keep in mind, the I times I is a pair. One I comes out, and the other I disappears. We have another pair. We have 4 times 4. One of the 4's will come out side, and the other 4 disappears. So there's nothing left over. Therefore, for the first x, since I comes out and 4 comes out, we have 4 and an I that comes out. And there's no numbers inside the square root, but we have the +2. And then we do the same for the other one. Keep in mind that there are no two numbers that are the same that will give us -16. So we just break down +16 and write 4 times 4. And we break down the negative, which is an imaginary number, I times I. We do exactly the same thing. Look for pairs of numbers. The I comes outside, then the other I disappears. The 4 comes outside, and the other 4 disappears. So therefore, the second x will equal -4i. Remember, there was a negative to begin with. And we have +2. Therefore, our solution set is 4i plus 2, comma, -4i plus 2. And there's our solution set. Our next example will have a quadratic x squared that will have an x that's added to it. If there is an x that's added to it, the technique that I showed you will not work. Let's suppose that x squared plus x is equals to 2. Because there's an x, we no longer have a square. We have a square plus a rectangle. This x is actually a rectangle that's added to this square. So we don't have a square to begin with. So if there's this x term, the only way to solve these problems is to move everything over to the other side and get the problem to equal 0. We now have x squared plus x take away 2. We just switch the signs when we move anything across the equal sign. And we now have equals 0. So if there's an x term added to the quadratic, we can no longer use the technique earlier. Instead, what we do is we move everything over and make it equals to 0. Now you're going to draw 2 lines to represent two numbers that must multiply to give us this 0. This problem is actually modeling the area of a rectangle, which equals 2. And we need to move the 2 over and make it equals to 0. So now we have this polynomial that needs to equal 0, or this polygon that needs to equal 0. We then find the two numbers to write on the blank by using 3 steps. So on the side, you start with the first number, x squared. Find two numbers that multiply to be x squared. Well, that's x times x. And then what we do is we move on to the third number. And we do the same. We find two numbers that multiply to be the third number. And then the third step will be to find two numbers that add to be positive x. So you can draw a line and put a cross sign between them. And draw lines but put a dot everywhere else. We need two numbers that multiply to be -2. Then what we're going to do is cross multiply to find two numbers that add to be the third number, x. So we know that a +2 times a -1 equals a -2. And if we cross multiply these two numbers have to add to be the third number. And it does. 2 plus -1 equals positive x. Therefore, the numbers that you write on the blanks above will be up and down. It'll be these numbers that are up and down. So we have x plus 2 on the first line, and we have x minus 1 on the second line. Be sure to write parentheses since these are multiplied together to give us the three numbers x squared plus x minus 2. Now that we have the two numbers, or the two factors, we take each factor and set them both equals to 0. And we solve for x. We take away 2, and we have x equals -2 for one answer. And then we add 1, and we get x equals 1 for the other answer. Therefore, my solution will be -2, 1. For this method to work, you must be able to make all three statements on the side. You have to make all three of these statements true. If all three statements cannot be made true, no matter what numbers you put on the blanks, or whether you switch the numbers around, if you cannot get the 3 steps to check, then you need to use the last method. Here is our last example. We have 2x squared plus x equals negative 1. Notice again that in this problem, we have this plus x. If there's a plus x, the only way to solve a quadratic with a plus x that's added to it is to make the problem equal 0. So, we need to move the negative 1 over to the other side so that the problem will equal 0. We have 2x squared plus, there's a 1x equals, plus 1 equals 0. Now we draw two blanks. 1, 2 equals 0. And we come over to the side and we try to find two numbers that will multiply to be the three numbers up above. The first number is 2x squared. That equals 2x times x. The second number must be the third number, which is plus 1. And we're trying to get the middle number, which is plus 1x. The only factors of 1 is 1 times 1. And when we cross multiply, keep in mind in the third step, you have to add the cross products. We have, in our first cross product, 1x, and in our second cross product, we have 2x. Notice that x plus 2x is false. And if we switch the numbers, 1 times 1, we still will get a false statement. And there is no other factors of 1 to play with, nor are there other factors of 2x squared to play with. So we know that this method will not work. We can't find the factors. So we have to use a different method. Now to find the x, we simply use a formula. This formula can only be used when the equation equals 0. And we typically use it when you can't get all three of these steps to be true. So you use this if it can't be true. You use this formula. Negative b, which is simply the second number, plus or minus the square root of b squared minus 4 times the first number, which is 2, times the last number, c. And then we divide the whole thing by 2 times the first number, a. Now we simply replace the a, b, and c with all the numbers up above. We have a negative 1, put the b in parentheses, plus or minus the square root of 1 in parentheses squared, minus 4 times the first number 2 times the last number 1. All over 2 times the first number. From here, we simply simplify the problem, and that will produce our two solutions. So we get rid of the parentheses by multiplying. The square root stays the same. 1 times 1 is 1. 4 times 2 times 1 is 8. All over 2 times 1 is 2. Then we have negative 1 plus or minus the square root of negative 9 all over 2. Then we look for pairs of numbers. Keep in mind that the square root of negative 9 can be broken down using I times I, which is the negative 1, and 9 is 3 times 3. Then one of the pairs comes out of the house and the other disappears. We have another pair, so the 3 comes out and the other 3 disappears. So our final answer is negative 1 plus or minus 3i all over 2. And so therefore, our solution set is negative 1, be sure to split them up, plus 3i over 2. And negative 1 minus 3i over 2. And there's our solution set.